Question 2 asks you to consider the lines L1 and L2 with their respective equations. You're asked to find the point of intersection of L1 and L2. So that's where both the x and y values of each line will be the same. So you're solving a pair of simultaneous equations. We could do this algebraically, but being paper 2, we don't need to. Our GDC can do it for us. So I go into menu and then equation, which is on A. It's a pair of simultaneous equations. There are two unknowns, y and x, and it gives me my matrix. Now it's important to note here that it asks for something times x plus something times y is equal to something. So I need to rearrange my equations to be in that form. So L1, I'm going to add x, or add 2/3 x, to both sides. So I have 2/3 x plus y is equal to 9. And L2, I'm going to subtract y from both sides and add 19/5 to both sides. So 2/5 x minus y is equal to 19/5. I don't really like having negative symbols in my equation, but there are other ways to rearrange that. Minus 2/5 x plus y is equal to minus 19/5 is exactly the same equation. I then type those two equations into my GDC. So I have equation 1, I have 2/3 x plus y is equal to 9, and then I have 2/5 x minus y is equal to 19/5. I press F1 to solve, and I get my equation for part A. My point of intersection even is 12,1. Then I'm told there is a third line L3 with gradient minus 3/4, and I'm asked to write down the direction vector of L3. Now I can imagine this causing a number of problems, because my direction vector tells me how I'm going to move in x and then how I'm going to move in y, whereas my gradient is my change in y over my change in x. So I just need to be careful when I'm thinking about that. And my gradient here is minus 3/4. In other words, my change in y will be minus 3, and for every time I move minus 3 in y, my change in x will be plus 4, and therefore my direction vector will be plus 4 minus 3. Or alternatively, you could have any other integer multiple of that vector. Direction, it doesn't matter what length it is, so I could have minus 4, 3, that would be the most common other one, but equally I could have 8 minus 6, or minus 8, 6, and so on. I'm then told that L3 passes through the intersection of L1 and L2. I'm asked to write a vector equation for L3, so I know it's going to be in the form R is equal to A plus, and then S times D, where A is a position vector and D is a direction vector along that line. So in this case, I know I'm going through 12,1. S is just some parameter that lets me move along my line, because it's some multiple of my direction, 4 minus 3, and I have my final answer. Looking at my mark scheme, for part A, I get a method mark for any valid approach, equating my variables, and then I get both marks just for stating 12,1 as my intersection point. For part B, I get a mark for any multiple of minus 4, 3, of which I am a multiple of minus 1. And then part C, I get a mark for any correct equation for R is A plus TB, any parameter 4t. You might see lambda, that's quite common, where A is a position vector for a point on L1, B is a scalar multiple of minus 4, 3. So my example works there, as does their example. And that's 5 marks in question 2.